Good morning, physics students, and welcome to Physics. It's Mr. Finn coming at you again from neighborly Northville, trying to get a little bit of continuity here. We have a continuity plan for our school system. It's been rolled out. Hopefully you've received some communication on that through the email system. If you haven't, I will give you the lowdown on what we're doing in regards to physics. So I apologize for being offline the last couple of days, guys. We had some teacher discussions and meetings, and we had to hammer out some things. As a result, here are some of the highlights. Number one, the Google Meets for our class, regular physics, will be on Tuesday, Wednesday of every week. First hour and second hour, Tuesday, Wednesday, 11 a.m. and 1 p.m. respectively. Third hour, 11 a.m. on Wednesday. Fourth hour, 1 p.m. on Wednesday. And then on Friday, by the way, Thursday would be for fifth and sixth hours, so we don't have any regular physics those hours. But Friday, I do have some office hours at 10 a.m. So if you absolutely have to get on and check it out, I'll be available by email or I'll have a Google Meet with a link, whatever you prefer. If you had extra questions, Friday is the day on every week. So that gives us some routine that we can go by. A couple other things. I'm doing a little bit of a Google form, not a huge one, just a couple questions on series circuits. Remember, that was the topic of last week. So that will be today's Google form. I want you to fill that out right after you watch this video, just to make sure that we are good on series circuits. Also today, I'll be doing an intro to parallel circuits. So we're going to have to be able to move between the two just as easily. So I want to put the Google form together for circuits, series circuits today. Friday, that means tomorrow. Friday, there's an opportunity to fill out a Google form on rotation. This will be an addendum to the test that we took before break. An addendum. So that means I'm going to merge some of those scores with your test scores on rotation from before we left. Now, I really want to isolate those students who are really at 72% or below. If you're above 72%, you're pretty much proficient, so I'm not going to spend my time grading those. But for those of you who are had a really terrible time on rotation and you wanted to get another chance at that, Friday, 3 p.m., your Google form on rotation. And I'll do a slight review on that on Friday's video. But today, we are after parallel circuits. Now, what in the heck is a parallel circuit, you might ask? Well, if you'll remember from our series videos, that was one in which the current had only one path which to travel. So one complete loop all the way around. But a parallel circuit means that there is multiple paths for current to travel. Let's go to the magic whiteboard and we'll get a look-see. Okay, guys, we're back. Let's take a look at a series or a parallel circuit example real quick, and you'll see what I mean about not having the same path. Here's my voltage supply, a 6-volt supply. Remember, that's 4 D-cell batteries. We have current or charge coming out of the front of that battery and moving down. It gets to a point right here. We're going to call that point A. That's my split point. At that point, current is going to branch off into 2 pieces. One going up this route from A over to B. So I got point A and point B here. But another current, not the same amount, would go this way because there are multiple paths for the current to travel. Because there are 2 separate paths. Both points, this route and this route, connect points A and B. Once the current is at point B, it will proceed back to the back of the battery again. So this defines a parallel circuit when there is more than one way for the current to go from the front of the battery to the back of the battery. Now, there are some rules that are slightly different than series. So let's take a look at those. Number one, we don't add resistors together. We apply Ohm's law individually right out of the gate. So that would mean that 6 volts divided by this 1 ohm resistor would yield 6 amps. And this 6 volts divided by this 2 ohm resistor would yield 3 amps. Let's make that change. Okay, guys, here's what we have right down the bottom here. I designated this as I sub R1, which means the current that goes through resistor 1, that's the blue current up here. That blue current would be 6 volts divided by 1 ohm to give you 6 amps. Let me put a little blue dot here so you know that the current that we found is the one that goes through the top branch. That's through R1. What about R2? The current through R2 is simply 6 volts divided by 3 ohms. Well, that would give us, 6 volts divided by 2 ohms. It's a 2 ohm resistor here. Well, that would give us 3 amps. And that's a green route. I encourage you guys to use your colored pencils if you have them at home. So let's put a green dot right there, signifying that's the current that goes through this branch. Remember, both blue and green current go between points A and B, from right here to right here. So, the next rule we have for parallel is we're supposed to add currents together to get a total current. Well, that would mean the branch currents of 6 amps and 3 amps must be added together to give you 9 amps right there. Now, my friends, you may be asking yourself, Mr. Finn likes to ask, hey, where is it? Where is it 9 amps? Remember, in a series, that answer would be everywhere, but not in a parallel. In a parallel, it can only be the total current where you are not in a branch. That must mean right up here, before you get to point A and after you leave point B, you would have a total of 9 amps. So the battery is supplying 9 amps, which splits at point A. It becomes blue, or 6 amps in the northern part, and 3 amps in the southern route, or the southern part. So our add currents together to get total current. I total for the circuit is unusually large, 9 amps. Thirdly, we're going to use Ohm's law to determine the resistance total. Now remember, we said we could not add resistors together in parallel. That was something we did for series, but not parallel. Instead, we're going to use Ohm's law for the total. On Monday, I'll show you a shortcut for that. But here's my resistance for the total. 6 volts, which is my total voltage, divided by the total current, 9 amps. And what's something is funny here, guys, you get 0.66 ohms. 0.66 ohms, or 2/3 of an ohm. It's not 3 ohms, it's not 2 ohms, it's not 1 ohm. It's 0.66 ohms. I wonder how that came to be. Clearly, in a parallel setup, it looks like our total resistance is going to go down. And that's true because our total current goes up. So maybe, if we have a lesson of the day today, we could say that in a parallel, my current goes up as I add more bulbs, but my resistance goes down. There we go. What's the last piece of this puzzle? Remember, all of these rules are on page 554 in your book, or 553. One of the last things we're going to talk about before we get to Monday's lesson is each bulb or branch gets the same amount of applied voltage, same as the total. So from A to B, it's going to be 6 volts of voltage drop. 6 volts, no matter which way we go. If we go the green route, it's 6 volts. If we go the blue route, that's 6 volts. 6 volts in either case. Well, that's it, guys. A pretty simple start. Tomorrow we're going to do a little review on rotation for those of us who are taking the Google form on rotation for Friday. And on Monday, I'll get back together again to discuss a little bit more in depth some of the issues with parallel circuits. But for today, let's just stick with the basic rules. Number one, we applied Ohm's law to get my branch currents. We added those currents together in the branches to get a total current. We used Ohm's law for the total to come up with a resistance total. And finally, we recognized that each branch is going to take the exact same amount of applied voltage. Okay, guys, let's wrap up then. Okay, guys, let's take a look at this. After we get done with this video, I'm going to have you guys fill out a small Google form to see how you're doing on series circuits. Now remember, we had some homework problems. I want to go through some of those tomorrow with you on the video. So let's see how you do on series circuits. Get those homework problems done. We'll go over those problems tomorrow, and we'll do a review for rotation for all of you who are taking the rotation addendum. And then on Monday, we'll come back to parallel circuits, and we'll get a little bit more in depth. I'll figure out how we're going to collect homework, guys, but do me a favor and just keep up with your stuff. Maybe I'll put those homework questions on a Google form to be easy to collect. Okay? Have a great day, guys, and we will see you tomorrow.